This is Chapter 10's exam review. We are looking at solving systems of equations, specifically just linear systems. So we're looking at equations of lines, and we're specifically going to look at two lines. Where do they intersect? And that ordered pair will be the solution to our system. So in 10.1, just getting started and looking at what does a solution do? What is it? What does it look like? What's so important about it? So is the ordered pair 11,8 a solution to the system below? System being two equations. So does it work for both equations? We're going to explain by showing a check. So all we have to do is plug in 11,8 to both of them and prove that those values work for both. So starting with this one, we're going to replace the y with 8. We're going to replace the x with 11. We're going to solve both sides of the equation, and we see that it works for y equals x minus 3. So 11,8 is a solution to this, but is it a solution to the system? That means it has to work for both of them. So plugging in for x, that's 11, plus 5 times y, which is 8, equals 50. So we end up with 11 plus 40 equals 50. We get 51 equals 50. Which means 11,8 is not a solution to this equation. And so therefore, is the ordered pair a solution to the entire system? We would say no, it must work for both equations. All right, and then we moved into solving by graphing. So we know that we have y equals mx plus b with our slope and our y-intercept. And so when they're in that nice form, very simple to graph. You start at the y-intercept and you put your first point, and then you use your slope up and over, rise and run to plot your next point and your next point and your next point. So we're going up 5 over 7. Well, that's not going to be on our graph. But we need to understand that this is going to go up this direction somewhere. So when we work back this way, make sure you're going down 5 and to the left 7. A lot of times students will go down 5 over 7 and they create a negative slope. This is a positive slope. So we're going down 5, which would go down to 3 from 8, down 5, and over 7 gets you to negative 7. And those are going to be the only 2 points that we can fit on this graph. Okay, so that line looks like this. And then this one starts at positive 2 and goes down, because it's negative, down 1 over 7. So down 1 over 7. Now that doesn't help us solve this system, but if we follow this line back this direction, it's going up 1, left 7, up 1, left 7. So it is going to hit right here, which will be the solution to this system. And so that point is the answer here. That is the solution. So I need the x and the y value. So the x value is negative 7, and the y value is positive 3, and that is the solution to the system. And we did it by graphing. Same thing here now. So going to negative 4, slope of 3 over 2. So up 3 over 2, up 3 over 2, up 3 over 2. And we don't know where this is going to hit, so we want to be precise. 1, 2, 3 over 2. Get as many points as we can. So following now, down 3, left 2, down 3, left 2. So we got lots of possible intersection points right there. And the other one starts at positive 4, and it's going to go up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. There's our intersection. So we don't have to be really precise over here. We know that this is going to be the solution to the system. X value looks like it's at 8, and the y value also looks like it is at 8. So our solution is 8, 8. Okay, and graphing isn't the only way to do this. In fact, if we don't have equations that are in that perfect form, graphing is a very tedious way to do it. So we looked at substitution and linear combinations. So starting with substitution, if we have either x or y isolated, we know that since y equals this, I can replace it for y in the opposite equation, no matter where y is, and then solve it. And then once I solve that equation, which will actually be for x, I can go back and I can find y. So I'm going to have to squeeze all these in. I'm going to move them over here. So I'm rewriting the second equation, but instead of y, I'm plugging in what y is equal to. So 11x minus 11. It is going to equal 5x minus 11. And what I need to do now is just solve this. So I'm going to go ahead and look at, I have an x on both sides. I'm going to go ahead and subtract the smaller of the two to keep myself in positive numbers. So I end up with a negative 11 on this side. I get 6x minus 11 over here. Adding 11 gets me 0, so 6x equals 0. Divide by 6, and x is 0. So we don't want to stop there. That is a value, so x is 0. So what we have to do is we now need to go back and find out what does y equal. So you're going to plug in for y. So you can do either equation, it doesn't matter. And I'm sorry, you're not going to plug in for y. You're going to plug in for x because that's what we have. Solve for y. So y equals 11 times, plug in our answer of 0 for x, minus 11. So that's 0 minus 11. So y equals negative 11. And so my answer is the ordered pair, 0, negative 11. All right, the next one, again using substitution, I see that y equals 2x minus 16. So I go to my other equation and I plug 2x minus 16 in for y because that's what y equals. So I'm going to move this all the way up. Negative 10x plus 11 times what y is equal to, 2x minus 16 equals negative 32. So this one's going to take some work. First thing I need to do is distribute. So I'm going to leave this alone. I'm going to get 22x. I'm going to do 11 times 16, and that's 176. Now it's positive times a negative, so that's a negative 176. I do need to combine some like terms here. So negative 10 and 22, that's positive 12x. Now I want to start isolating x, so I'm going to add 176 to both sides. So negative 32 plus 176 is going to be 144. And when I divide that by 12, I know 12 times 12 is 144, so x is 12. That means I need to go find y now. Now, out of these two equations, I would go to the second one. Again, both of them will give you the right answer, but this one just looks easier to work with, right? So y equals 2 times, plug in my answer, 12 minus 16. That's 24 minus 16, so y equals 8. So final answer here, x comma y is 12 comma 8. Next one is similar in terms of how we're starting. So y equals this, so I'm plugging it in for y. So 18x minus 2 times 9x minus 20 equals 40. Distribute. So that's negative 18x, positive 40. And when I go to combine like terms, the x cancels the x. 18 minus 18 is 0. These go away. And so I'm left with 40 equals 40. Since that is a true statement, I know my answer is all real numbers. Sometimes these eliminate and we have different numbers here, like 5 equals 40, and that would be no solution. All right, then 10.4 and 10.5, we started solving by linear combination, and that's when you actually add the two equations straight down and see what you're left with. This one we can go ahead and do right away. The whole point is we want either our x or y to eliminate themselves. So a 3x minus a 3x or plus a negative 3 will cancel. And so that's perfect. And so if we do 11 plus 5, we get 16y. And here we get 0. Divide by 16. Y equals 0. So we've already solved for y. And so all we have to do is go back and solve for x. Doesn't matter which one you go back to. So I'm going to do the first one here. So I rewrite it. I'm plugging in for y because that's what I have. 3x plus 11 times 0 equals 15. So this just becomes 0 and goes away. So 3x equals 15. Divide by 3. X equals 5. Final answer, 0, 5. Now this one I can't just add straight down because a negative 6 doesn't cancel a negative 6. So I want this to become positive. Either one, it doesn't matter. So what you actually do is you multiply by negative 1. So you end up with negative 2x, positive 6y, and 0 just stays 0. So now this one is gone. Okay, I'm going and I'm just going to do these two together now. So it's a 4 minus a 2, that's a 2x. A negative 6 plus a 6 cancels, and 24. So I divide by 2, x equals 12. Got to go back and plug it in. So 4 times 12, that's the x, minus 6y equals 24. 4 times 12 is 48. Oops, minus 6y. So if I minus 48, I have negative 6y, don't lose that minus, that's a negative, and I get negative 24. So I'm dividing a negative by a negative, so my answer is positive 4. Final answer is the ordered pair 12, comma 4. Okay, and the last one is set up to cancel. And in fact, you'll see the x's and the y's cancel. So x's, 4 and negative 4, cancel. Negative y, positive y, cancel. I cannot leave this side of the equal side blank, so it is a 0. And when I combine these, I get 3. Now that is not true. 0 does not equal 3, and so this is no solution. If these were to cancel and you had something that was true, like 0 equals 0, then that would be all real numbers. All right, and the very last piece in chapter 10 was solving linear inequalities. So we already solved linear inequalities, and we shaded part of the graph. So with system, we're going to shade the part that works for both. So first here, we have y less than negative 1. When we graph it, it's like graphing y equals 1. So you find 1, and it's the line that's always going to be at y equals 1. Now we need to be careful when we do these linear inequalities. We have to make dotted lines or solid lines based on the inequality itself. If it has an equal sign, it's solid. If it doesn't, it's dotted. So this is going to be a dotted line for y equals 1. Now it says y is less than, so that's going to be shaded underneath of it, but we're not shading all of that. It's just going to be the part that's underneath this that also works for this one. So this is in y equals mx plus b form. So starting at the intercept of 1, so that's actually going to be the intersection. The slope is 2, so 2 over 1. So up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Now I'm going to be more careful down here because I know that's where the shaded part is going to be. Up here, I don't have anything shaded. Oh, and that should have been dotted. That's my mistake. Dotted. If it wasn't in pen, I could erase it and fix it, but there's no equal sign. That must be dotted. And now this is also less than. So everything that's underneath or less than needs to be shaded. So that would be everything here. Everything underneath this is here. So what's the region here? We have 4 regions. This one, this one, this one, this one. What's the region that's underneath both of them? And that is everything down here. So again, this should be dotted. That's my bad. Not solid. Only time it's solid is when you have that equal sign. And then we're shading down here. All right, and then number 2, last one. Let's start here. This is going to be a solid line. It's starting at negative 5. This is a negative 1 slope. That's negative 1 over 1. So down 1 over 1. So it's just going to go diagonally through these boxes. And it's going to be solid. Now this says less than or equal to, so that's going to be under here. So when we draw the other line, it's going to cut this into 2 regions, and we're going to shade the one that works for both of them. It says y is greater than 3x plus 7. So 7 is up here. Slope of 3 over 1, that's up 3, 1, 2, 3 over 1, down 3, left 1, down 3, left 1, down 3, left 1. There's the point of intersection. Down 3, left 1, down 3, left 1. Again, cuts your graph into 4 pieces. We need to highlight or shade in. Oh, and I did it again. This one doesn't have an equal sign. I'm going too fast. This should be a dotted line. But it says greater than. So everything above this line, so from the 7 up, so that would be everything up here, it would be shaded. For this one, it's supposed to be everything underneath. So the overlap is going to be in this region over here. It's less than this line. It's greater than this line. And again, I apologize for not making that one dotted. This one should be dotted.